Alright, so in this section we're going to be looking at how to apply calculus 2 to parametric equations. So the various different things we can do is we can look at arc length and surface area from parametric equations, right? So for arc length, right, suppose we have some curve, right, maybe it looks something like this. And this is a parametric equation, so it's just going to be traveling like this. And now let's say there's some piece of this curve, maybe like from here to here, and I want to know what is the length of the curve, right? Like, how far are we traveling in here? So then this would be from t equals a to t equals b. And so our formula for finding the length of the curve is going to be the integral from a to b of the square root of dx dt squared plus dy dt squared. So this basically just says take the derivative of the x equation and square it. That'll give us this part. Take the derivative of the y equation and square it, and that'll give us this part. And we take a square root of their sum, integrate, and that will give us our arc length. So the big thing here is just going to be, plugging everything in correctly and then actually being able to perform the integral. So I'm going to solve out the first one for you most of the way, and then for the rest of them, I'll get everything set up, and your task is going to be to actually solve these integrals. All right, this is all going to go back to u substitution and past integration methods that we've used to integrate these. So let's look at example 1. So for example 1, if I want the length of this curve, the first thing I should do is find my dx dt. So dx dt will give us 3 minus 3t squared, and dy dt will give me 6t. So then my arc length from 0 to 2 will be the integral from 0 to 2 of the square root, so dx dt, so 3 minus 3t squared, and then we square that, plus dy dt, and we square that. And then, of course, dt. So then this will be the integral from 0 to 2, square root of, squaring this out, or foiling it out, we would get 9 plus 9t to the 4th minus 18t squared. And then squaring this, we would get 30 plus 36t squared dt. And so simplifying this, we should get the integral from 0 to 2 of the square root of, if we add all these together, we should get 9t to the 4th plus 18t squared plus 9 dt. Now I can factor this, and this will factor into integral from 0 to 2 square root of, we should have 3t squared plus 3 and then squared, right? This is the same thing as this right here. If you've forgotten how to factor, or it's just been a really long time, or you never had a good introduction to it, then please let me know and we can go over that. So then the square root will cancel out with this being squared, so we'll just end up with the integral from 0 to 2 of 3t cubed plus 3 dt. And that will give you, once you solve it out, 14. So when I put these dots in this video, that means here's a little bit of work for you to do, and you should arrive at this answer. Now let's look at example 2. For example 2, a similar scenario going on. I'll find dx dt, which is going to be 4t minus 1 over t squared. And I'll find dy dt, which will give me 4 over square root t. And then, so my arc length is going to be the integral from 1 to 3, right? Because that's the range of our t values we're looking at. Let's see, so we should have the square root of dx dt squared, so this will be 4t minus 1 over t squared, plus 4 over square root t squared dt. So from here, right, we'll definitely need to FOIL those out and square them. Maybe we get some cancellation of terms inside, or maybe we have some U substitution technique we can use. But I want you to practice that, so we'll put in the dots here. And however you evaluate it, you should come out with that this is going to be equal to, you should have 2t squared, t squared minus 1 over t, evaluated from 1 to 3, and of course I'm going to run out of room here. So let me move this over a little bit. And this will be equal to 50 over 3. Right. If you get something different, please let me know, or if you're stuck trying to calculate this integral, please let me know, and we can work through it. Another good reason to be practicing these will be that we're going to have stuff on the final exam covering those integration techniques, and so this is a good way actually to start reviewing for the final exam and reviewing this material. Now, example 3 is a little bit weird. In example 3, we're not given an x of t and a y of t equation. Instead, we're just given a Cartesian equation. But what I notice is that if I set y equal to t, then I can just substitute into this equation right here, that y equals t, and we'll get x equal to 5 minus t to the 3/2. So that's how we can convert this from a Cartesian equation into a parametric equation. Okay, and so then this means that we'll have the integral from, so another thing is what are our t values going from? Well, it says we're going from this point to this point, and the y value is our t values, so we're going from 1 to 4. So we'll have the integral from 1 to 4, square root, so let's see, dx dt, that will give us, so let's see, we'll have negative 3/2 times t to the 1/2 squared, plus, then I need my dy dt. Well, the derivative of t is just going to be 1, so this will be 1 squared, which is 1, and then dt. And then solving this out, you should get 8 over 27 times 10 to the 3/2 minus 3.25 to the 3/2. Okay. So now for surface area, this is, I think a lot of people get confused here, but I'm going to break it down and try to make it a little bit easier. So the key thing here is that if we have some parametric equation given by x equals f of t, y equals g of t, and our t values are going from a to b, then if we are revolving around the x-axis, then our surface area is going to be given by 2 pi times the integral from a to b of g of t times this square root. Right, so notice that this part right here, this is just from arc length. Right, so you can think of it as the arc length formula, and then we just need to multiply by the function that we're not revolving around. So if we're revolving around the x-axis, then we should be using our y function to multiply by. Okay? And so we'll do that integral from a to b. We have to multiply by that function and then multiply by 2 pi after that. Similarly, if we're revolving around the y-axis, then we need to multiply by the x function. Okay, so let me show you how this will work out. Suppose we have example 4, right? We have our x and our y function. We have a range of t values. And I'm being asked to calculate surface area. So surface area is going to be given by the integral from, so we use the bounds for our t values. So we'll go from 0 to 1. Now I need to realize we are revolving around the x-axis. So that means I'm going to use my y function. So we'll have 3t squared times, now we should have our arc length formula, right? So the square root of dx dt, which would be 3 minus 3t squared, we have to square that, plus dy dt. So it'll be 6t, and then we have to square that. Okay. And when we calculate this out, so I'm going to leave this as another practice problem, we should get 6 pi times 8 over 5. Okay, now let's look at example 5. So for example 5, it's going to be very similar. The only thing we need to do here is just be careful about what axis we are revolving about. So I'm being asked to find surface area, so we'll have surface area is given by the integral. We use the bounds for our t values, so again we're going from 0 to 1. And then the next thing I need to look at is what axis am I revolving about. I'm revolving about the y-axis, that means I need to use my x function. So this will be e to the t minus t. Then we'll have the square root, right? So now we're doing our arc length formula, so we'll have dx dt, which is e to the t minus 1 squared, plus dy dt. So being careful about this is going to be 4e to the t over 2 times the derivative of t over 2, which would be 1/2 squared. Right, and so this is essentially just 2e to the t over 2 squared. Oh, and then I should have a dt here, right? Okay, so then another practice problem. This should end up giving you 2 pi times e squared over 2 plus e minus 3. Okay, so make sure we're going back and doing these practice problems. So here in the surface area, all we have to know is how to integrate something, right? Which is generally just doing some algebra and then using one of our techniques of integration. And then we have to know the formula, right? So make sure you have these formulas down. And make sure you're going back and doing these practice problems to review over integrating stuff, right? And so we should have 2, 3, 4, if you want to count this as, 5 practice problems, right? If you get stuck on any of these, you can't figure out how to do it, whatever's going on, please feel free to approach me in office hours, and I'd be more than happy to go over these problems. Have a great week.